The following is an interview with Riccardo Storti, author of Quinta Essentia Parts 1 through 4 and creator of the Quinta Essentia Part 5 YouTube channel. His many papers can be found on ResearchGate and in the links in the description below. Riccardo Storti's recent paper on the lore of Robert Lazar has attracted the attention of the UFO community due to a recent post by Think Tank 528 Vibes on Twitter, with the announcement that Riccardo's scientific paper has verified one of Bob Lazar's key physics claims, namely the existence of a gravity B wave of 7.46 hertz. Although I could not find Bob physically stating that number in any video or audio interviews, as I tried to get the clip for this film, it is on the boblazar.com website, which apparently hasn't been updated in 10 to 15 years. And it can also be found referenced to Bob Lazar in Paul Potter's 2008 book, Gravitational Manipulation of Domed Craft. And while such waves have yet to be verified experimentally, there's a growing excitement about the apparent correlation between Bob Lazar's prediction and the prediction of Riccardo Storti's physics models, which have predicted the size of the proton and other subatomic particles down to quarks up to the size of the universe and cosmological constants as well. So Riccardo said that he was shocked when he learned that Lazar had predicted this exact value for the frequency of gravity waves at the surface of the Earth. I decided to email a source close to Bob Lazar to get that answer. Gene Huff is an old friend of Bob's and talks to him frequently. So here's what Gene Huff had to say when I asked him in an email. The 7.46 hertz was just the figure his lab partner Barry had made him aware of. They weren't tasked with confirming their calculations themselves, as they have to have everyone involved with that to have common denominators so the teams wouldn't waste time in coming up with their own variables and in doing so convolute everything. I thought that's what the answer would be, but I asked Bob anyway to make sure I'm giving you the straight scoop. So here's the interview, and if you can think of any ways to test this experimentally, please write them in the comments below. Thanks and enjoy.
On ResearchGate, the access to that Lazar article has I've had thousands of reads in the last 24 hours.
Yeah, all from that one Twitter post, isn't that?
Yeah,
it's just weird how one Twitter post can go so viral like that.
Well, it is, and look, just look, I assume. Well, look, I suppose it doesn't matter if we've started at the moment, so because you're going to edit stuff out. But I got contacted by Jeremy Corbell, actually, and Jeremy wrote to me. He obviously saw the Twitter post, and Jeremy reached out to me and said, "Oh, glad we can finally speak." And I have this thing, right? I have this thing, and look. First of all, I've got to say, given the way that we started, I have a tremendous amount of respect for you for the fact that you were able to be a man and come forward and say, look, sorry about what's happened. Let's start again. Right. So I've got a great deal of respect for that. It takes a big man to do that, by the way, right? Because most people don't do it. Anyway, I just want to get that off my chest. Back to Jeremy Corbell. So he contacted me and he said, glad that we can finally speak. My reply to Jeremy Corbell was not really pleasant at all, because I made it very clear to Jeremy that look, I tried to reach out to you via email on a number of occasions and via Twitter, and I got no reply. So for me personally, right, it is, and I wrote this in certain parts in red text, and I replied, I said, listen, when I speak, I expect people to listen, right? Because that's how a discussion works, right? That's how interaction works. One party speaks, the other party listens, and you swap. And I made it very clear and put that in red. And I said I also made it very clear, and I put this in red, that Jeremy, look, what you did by ignoring me was highly, highly, highly offensive. And because he made it clear in his wording that he had received my previous attempts at contact with him. And one of the key bullet points I put in there as an actual bullet point was that, look, I don't tolerate this behaviour from family members. So you can imagine where that puts you on my importance scale. And that's it. And I won't have a thing to do with Jeremy Corbell from now on. So I just wanted to mention that. So, I mean, I'm not looking to get fame or fortune out of this.
Well, he's got 20 times the audience I do. So if you were, you'd probably be going with him. So,
well, look, yeah, and I'm not just on that. And this is an important part of the pre-discussion, right? That I feel we need to have and needs to be said. I am absolutely dismayed with the internet generally around the topic of Lazar and people connected to him. So people like Corbell, George Knapp, even Richard Coulthard. These guys are all sensationalists. They're looking for sensational wow factor stories. They're not interested in peeling back the layers of the onion to discover the truth at all, in my opinion. Right?
Yeah.
I really couldn't care one way or the other about Bob Lazar's personal story. We've all got a personal story, right? Look, you know my story. I mean, I got blood cancer. I've got things to worry about. I don't care about people's personal story. What I'm interested in specifically is the science. So I couldn't care if Bob Lazar's story was completely fabricated. It doesn't affect my opinion of the situation at all. I couldn't care. I couldn't care if he found a document.
Right.
Put it this way.
Even if Richard Doty hired him and brought him out and gave him pure disinformation and made the whole story up with the Air Force OSI to trick John Lear, you still would listen and you know, even if he killed his first wife, he pimped a whole bunch of girls, ran brothels, and did all this stuff to accuse of him. It doesn't matter because all that matters at the end of the day is the actionable intelligence, which is the science, right?
Exactly correct. Exactly correct. And the analogy that I use is, look, for all I know, for all I care, Bob Lazar could have been a janitor at S4, and he found a document that was in a rubbish bin or a toilet. What matters is the content, the content of that document with respect to testable science. And the only bit of testable information that Bob Lazar or anybody, and although I'm talking about Bob Lazar, it applies to anybody and everybody. The only bit of testable information that's ever been supplied by anybody, to my knowledge, any of these so-called UFO whistleblowers, has been one piece of information by Bob Lazar, which is that 7.46 hertz frequency claim, right? I haven't seen any evidence by that David Grush guy who, went in front of Congress, US Congress, etc. Nothing. So the only thing that I'm interested in is the science, the testable science underpinning anybody's claim. And as far as I know, Bob Lazar has made the only testable scientific claim anywhere. So I'm happy to be corrected. If there's other stuff, I'd be more than happy to look at it. But nobody's come up with any numbers of any description. So, for example, this David Grush guy, because I watched the congressional hearing on it, and Jeremy Corbell featured prominently in the background, and so did George Knapp, etc., in the background behind David Grush. Now, David Grush provides nothing verifiable whatsoever. It seems inconceivable to me that someone apparently that was high up in the intelligence community, that was well connected, cannot provide not one shred of scientific or engineering evidence. For example, the mass the weight of the craft. It's never even mentioned. It doesn't matter how advanced a space alien civilization's technology might be. We can weigh, we can test to see how much something weighs. How come that's not even provided? Absolutely nothing is ever provided. Nothing technical, no propulsion ideas, absolutely nothing whatsoever, with the exception of Bob Lazar. And even then, the only testable claim that can be validated, and I believe I validated it with the work of Todd Desiato as well, is Bob Lazar's 7.46 hertz frequency claim, which doesn't even require any of Bob Lazar's story to be true, by the way, because it's a quantum vacuum property of the Earth at its surface. It sits completely independently of the Lazar story. Doesn't need element 115, doesn't need any US government conspiracy, it doesn't need space alien technology, doesn't need the existence of Area 51 or the existence of S4 or anything. It sits entirely independently of the entire story. It's a quantum vacuum property of the Earth at its surface, and it is all based upon, the number is all based upon work done by Joseph Fourier over 200 years ago. That has been, it's mathematical. It is irrefutably incorrect. It's not even physics.
So
it's pretty much mathematics.
Let's go over some of this stuff now, because you know, I'm a little bit more familiar with your work than maybe most people are.
Yeah.
You wrote a book, a 4-part book called Quinta Essentia.
Yeah, correct. In fact, yeah, there's actually 5. So there's part 1, which was actually written by a guy named Jeff Deemer. I edited that. So he actually wrote that part, but based upon my work, I edited that book. So it's part 1. Then there's part 2, part 3, part 4, and then there's a summary book, which is parts 2, 3, and 4. And my YouTube channel is basically part 5. So that's going to be no text, it's just the content that's on there, and that's pretty much complete as it is.
And if people want to find your YouTube channel, what do they search for?
If you type in Quinta Essentia, part 5, space part 5, then you'll find it. That's it.
Oh, yes, that's it right here. Yeah, I was looking for it under Quinta Essentia. I couldn't find it. But yeah, the part 5 should narrow it down if people
go. So
now you've posted a bunch of videos the past couple of months. I've been seeing you going over a lot of different stuff with your theory. What's the basis of this? It's something called Buckingham Pi theory.
That's the tool. That's the basic tool that's used. But the essential idea, the essential theme that travels all the way from particle physics right up to cosmology, the central idea about this is the idea of all matter existing in equilibrium with the space-time manifold surrounding it. So whether you take a proton, a neutron, electron, or a planet or a star, doesn't matter. That object, that matter, is in is in equilibrium with the space-time surrounding it, or more precisely, rather than space-time, which is a derivative of general relativity, it's in equilibrium with the quantum vacuum surrounding it. Right? So in 1915, Albert Einstein published his now very famous theory of general relativity. But by 1925, it had basically been confirmed by the scientific community that the true nature of reality was quantum. So once you strip away, so essentially by 1925, Einstein's work had been basically overturned by 1925. right? Now, what makes Einstein's work so powerful and continue to this day is not the theory behind general relativity, it's the mathematical method that sits underneath it, that underpins it. If you strip away the mathematical method, the mathematical technique, which he himself, Einstein, did not develop in isolation. He had the work, he had the assistance of professional mathematicians to help him out. So if you strip away the mathematics underpinning general relativity, you're not left with much, right? Because it is a known physical fact that the true nature of the universe is quantization. And general relativity does not address in any way, shape, or form that link to quantum mechanics. And it's a big question mark. It's a big issue in physics at the moment. So, and in fact, what I've done, one of my, see, there you go, that's Einstein's field equations. So if you look, you can find on my channel, I can't remember the number of the video, but I actually produce a video where I show how a link between general relativity and quantum mechanics can be made by basically taking the number 1 and decomposing the number 1 using Fourier harmonics. So when you do so, a Fourier series is fully quantized. Okay, so you have the odd harmonic sequence 1, 3, 5, 7, 9, 11, etc. So that sequence is a quantized sequence. And you can use Fourier mathematics to decompose the number 1 into a spectrum of waves. And I show in my videos how that's actually done. And I demonstrate that technique in the simplest possible way that I know how.
Which
in
video
one of
is
my
that?
Lazar videos.
Which one is this? Can you point it out? Which number?
Yeah, look, I'd have to see. Let me have a look myself, because I can't recall off the top of my head. I've done quite a few.
Mm-hmm.
But if you go to, let me see. If you go, oh yes, okay. So if you go to the EGM playlist, you'll see video number 36, so 036. It's quantum integrated general relativity. And what I do in that video is I show that if you multiply Einstein's field equations by a quantized version of the number 1, right? So at the end of the day, you're only all you're doing is multiplying his field equations by the number 1. So it changes nothing, right? It changes nothing to the outcome. Doesn't change his equations at all. But what it does is decompose his equations into quantum form, into a quantized form, by multiplying his field equations by the number 1, a special version of number 1, let's call it that, right? So you don't change the outcome of Einstein's field equations at all, but what you have done is then you've quantized it. So you've integrated it then to quantum mechanics, because it is fully quantized by the way that I've done it. And that's it there. You've got it right there. So that's the missing link between quantum mechanics and general relativity. It's just the number 1, which is quantized. So when you add all the harmonics associated with this quantum process, this quantized process, which is just a Fourier distribution, you get back to the number 1, which changes nothing. So does that make sense?
So you're taking, sorry, and I have my friend Michael here, who's a better scientist than I am, but
yeah, sure.
So this, I'm essentially understanding correctly. You're taking Einstein's field equation, you're multiplying it by this special version of 1, which essentially breaks it up into all of its Fourier series.
Bang on. That's correct. That's exactly right. So
One quick question, though. We've known since Ramanujan's time that if you manipulate an infinite series, you can make it say almost anything. So,
I've got to stop you there. It is not, and in reality, it's not an infinite series, right?
all right.
The way it's been applied, it's not. And the reason it's not an infinite series is because there is a finite amount of energy available, a finite amount of quantum vacuum energy available at any point in space-time. So the series will have an upper bound limit, right? So it's not infinitely broad. If you were looking at it purely from a mathematical perspective, from a Fourier series perspective, purely as a mathematician, yes, it does extend to infinity. But when you add the fact that, or you incorporate the fact that there's a finite amount of mass energy present at any point in space-time, it is no longer an infinitely broad spectrum. So, for example, at the surface of the Earth, the number of terms that you'll have in that Fourier series is, I'm going from memory here, I'd have to check it out, I'd have to look it up to be sure, but I think it's 1.45 by 10 to the 28.
That's still quite a lot.
That's right. So it's so many that you cannot distinguish whether it goes to infinity or anything else. It is so many terms which all adds up to the number one.
So this Fourier process, is this the sort of like non-commutative algebra thing that people do when they're like, you can take the even terms and make the bosons and the odd terms and make the fermions? Is that the sort of, or is it something else?
It's something a bit else. So the even terms drop out, they sum to zero. So you only ever use the odd terms.
Gotcha.
So you can dismiss the even terms totally. Right. So the sequence will actually go 1, 3, 5, 7, 9, 11, all the way up to 1.45 by 10 to the 28. In the case of the surface of the Earth. Right. So what happens? So what actually happens is this. Okay. And I'm glad you're on board, Michael, because you will hopefully appreciate this. Let's imagine that you start with a bare vacuum. Okay, now what's a bare vacuum? Good question. I'm glad you asked. All right. A bare vacuum is this. Let's imagine we've got a toy universe that has nothing in it whatsoever. It has no matter and no energy. That is a bare vacuum. Now, a bare vacuum can't possibly exist because we know for a fact that as an absolute minimum, the quantum vacuum exists in any 4D, in any region of space-time. And its ground state is the 0-point field. So we know this for a fact. This is experimental. This is fact, right? So we know this for a fact. So a bare vacuum itself can't exist. You've got to start with the ground state of the quantum vacuum, which we call the 0-point field. Okay. Now,
Sure.
that spectrum, that 0-point field spectrum, if that's all you have in your toy universe, that starts. It has a base value of 0 hertz and extends all the way up to infinity. Right? Okay. That's for the toy universe with no matter or energy in it whatsoever, other than the 0-point field. As soon as you drop just even one electron or one additional photon into that toy universe, you modify those extreme limits from 0 to something else and from infinity to something else. So what that means then is that the infinite energy in a vanishing volume problem that is a real thorn in the side of quantum electrodynamics disappears. Because if you add an electron, you now no longer have a lower bound limit of 0 hertz, it's something else. And you no longer have an upper bound frequency of infinity, it's something else. Just from one electron.
So this is one of those models where effectively the particles are kind of like holes in the vacuum, and the vacuum has all the energy, but the particles have less energy.
Well, look, I'd like to say yes, but
Not quite.
no.
Got you.
I'll say no to that. Okay. So what happens then is when you add something like a proton or a neutron or electron to that toy universe, the lower frequency limit upshifts and the upper frequency limit downshifts, right? If you add all of those quantum vacuum frequencies together, what you end up with is the rest mass energy of whatever it is that you dropped in that toy universe.
Interesting.
Right. So the quantum vacuum can never contain any more energy than what you add, if you excluding, of course, the mass energy that exists there to begin with the 0 point field, right? Because the 0 point field has to have mass energy of its own. So if we look at cosmology, for example, now we know from experimental observation that the universe is expanding at an accelerated rate. Now, what that implies, and you and I have sort of had this discussion in the past, is what that implies to cosmologists, and I can send you the specific link that talks about this from a guy named Ethan Spiegel, who's quite a serious physicist. What that implies is that the mass of the universe is increasing, right? But that contradicts what we all know to be the most fundamental law of physics, right? So we know that. Okay, so
well, I wouldn't go so fast there. So if you consider the universe as the inside of a black hole, then the boundary is part of an open system. Stuff can fall in the black hole. So conservation of energy may be violated, but if it's an open system, that's not necessarily the case.
You're making an assumption.
Oh, what?
Well, if we're inside a black hole, what if we're not? Who knows?
Well,
Right?
I mean, you have to assume that for conservation of energy, you have to assume that the boundary is a closed system, right?
Well, yes, you do. Right? Yes, you do.
Either
However,
way, you have to make an assumption. You have to just pick.
well, yes, you do. But what I'm trying to get at is that dark energy. What I'm trying to get at is all relates to dark energy, right? So we know for a fact that dark energy is 67 to 68% of the mass of the universe, right? So
unless there's another reason for the redshift, for example, a tired light model or something else similar to that.
look, that can take us down a whole, rabbit warren.
Right. I mean, you have to interpret the cosmological redshift as an acceleration, and that's also an assumption too. But go ahead.
Yeah, correct. Okay, well, it's not right. It's not an assumption. It's actually measured. I mean, the guy's got bloody Nobel prizes for this, right? So
right. Well, so the redshift is measured, and then it is assumed that that's an acceleration, technically.
Yeah, correct. Right, correct. So, but it's widely accepted, right, that the universe is not only expanding, but its expansion is accelerating. Okay. Now, what we know about dark energy, or what the standard scientific dogma is about dark energy, as you know, 67 to 68% of the mass of the universe is contained in dark energy. Right. So the big question is, what is dark energy? Okay. What I propose is this. I propose that there's actually a how shall I describe it? A continuous energy loop, right? So I claim that whole problem is solved by matter evaporating, right? So matter actually evaporates. It radiates gravitons. So the space-time manifold that's curved according to GR, that curvature sits there and is permanent. So if you've got, some mass there, it could just be a proton. That proton is infinitely stable. It'll bend space-time, and that space-time curvature around that proton is permanent. That's what GR says, right? I dispute that. What I say the process is actually happening is that proton is radiating gravitons, and those gravitons are being absorbed by the quantum vacuum, right? So underneath what we see as the 0 point field, so the 0-point field manifests itself, at least in my view, as the Casimir effect. Okay, so what feeds the Casimir effect? Where does it get its energy from? Well, I argue its energy is coming from the dark reservoir of quantum potential energy. So all matter is actually evaporating over cosmological time. And I've actually calculated the value, and it has a minimum value of 10 to the 13 gigayears.
Well, there's the one question. The other question is, like, if you have a gravitational near field of these objects, it's not a wave equation per se. They're sort of virtual gravitons, so they don't contain real energy. They contain reactive power or imaginary energy, however you want to consider it. So, I mean, maybe there's a way of thinking of it as energy, but it's not like it's not mathematically equivalent necessarily to the standard energy we think of when we think of energy.
Look, I'll have to have a think about what you just said. I'll have to kind of digest it a bit, right? But there are two extremities in nature that the entire scientific community refers to ad infinitum, and it drives me to great frustration. Absolute zero anything has never been experimentally observed. It's a myth, right? Infinity anything has never been observed, can never be observed. It is a myth, right? So the idea of photons having zero mass, it's religion. There's no science to that whatsoever. Photons must have mass because zero anything doesn't exist.
So
right?
On the flip side, though, if you have bounds at 0 and infinity initially, and then you add a photon or an electron to your universe, then how does the bound move from infinity to a finite value while only embodying a finite amount of energy for the particle?
Because you can never have zero and infinity to begin with. So the only way that you can have zero and infinity to begin with is a bare vacuum without even a 0-point field, right? True nothingness. Okay. As soon as you have a toy universe, for example, with just a bare vacuum, a toy universe can't exist without a bare vacuum. At the very least, you've got to have the quantum vacuum in there in its ground state, which is the 0-point field. Right? So immediately you can never, ever, ever, not in any imagination or under any religion, have zero mass for anything. So this idea of photons having zero mass and gluons and blah, 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 it's religion, right? There's no science to it whatsoever, right? Now, that becomes important because that means that you can then explain why 60 to 67% to 68% of the universe's mass exists in the form of dark energy. If dark energy is actually the Casimir effect occurring on a cosmological scale, right? So imagine you've got matter evaporating in the form of gravitons, which have mass. They're not massless. They have mass. That mass is being absorbed by the 0-point field. It is stored as in a dark reservoir of quantum potential energy that can never be accessed. That is reality that we can never actually reach. We see evidence of that reality in the 0-point field via the Casimir effect. So you've got these virtual particles, these positive and negative particles, these particle-antiparticle pairs popping into existence that is driving, in my view, cosmological expansion at the accelerated rate. And I've run all the numbers, I've got the graphs and equations, and I demonstrate it all, right? But that's that's what I think is actually happening. And a key factor about this is that zero anything does not exist. So as soon as you hear in standard scientific dogma, photons are massless, well, call a priest, because that's what you're doing, right? You're bringing religion into it. There's no evidence for zero anything. Would you agree with that?
Not necessarily, but let's go back to towards Lazar's stuff, perhaps, or actually, yeah. I mean,
Yeah,
maybe is there more to the point?
So basically, what I'm saying about my most simplified message, and this will then dovetail into Lazar, is that using Fourier harmonics, right? So using standard Fourier stuff from 200 years ago, you can break down the number one into a spectrum of frequencies, and that spectrum of frequencies can quantifies general relativity. You can use it to quantify general relativity, and Jeremy's got the video number there, number 036.
Yeah, if you have these papers, it might be helpful to go through some of these the papers that are associated with this, so we can see some math in more detail.
Yeah, look, that would take, if we do that, to be honest with you, it's going to take ages. Look, if we pick just,
that's fine. Yeah, I mean, yeah, just
if
give people. We don't have to go too much into the detail. Give people the general gist of what the
we're going to lose a lot of the
idea
technical
is.
people if we go into that kind of detail. If
Yeah,
people are
look, I
able
think-
to go into that themselves, we just need to show them where the water, lead the horse to the water. You know?
That's right. So look. I see. I would say the first step for most viewers would be just to watch the content I've got on my YouTube channel, and watch it in order. Right, you've got to start at video 001 and just follow the sequence. Just watch the order all the way through, one by one, because I build, and then in each one of those videos, it links to the papers if you want to see the math.
Got you. Right? Okay, that's fine.
So that's the best way. So now, with respect to Lazar, so what I've done with Lazar is I've completely ignored any and all media hype around the guy, around Bob Lazar himself. So the media tends to play the man and not the ball. Now, I get this. I understand this because Americans in particular understand the concept, or they're pre-programmed to play the man and not the ball because of your American football, because that's exactly what it's about. It's about playing the man and not the ball. If you, however, look at European football, soccer, it's the opposite. You play the ball and not the man. So I completely understand why Americans tend to focus on credibility, etc. So I've put all of that aside. Okay?
Well, it's a symptom of a society in decline when people are fighting over scraps like that. They have to focus on sociological stuff instead of on the fundamentals of like building something, because it becomes too hard to build something relative to, fighting for what's left. It's catabolic, like Tim Ventura was saying. It's a catabolic collapse.
Yeah, correct. And I agree with you. I think that's a brilliant summary, by the way. Now, with respect to Lazar, okay, so Todd and I developed a technique a mathematical method to determine all of the frequencies within the quantum vacuum surrounding an object, right? So its lower frequency limit right up to its cutoff frequency. And it's going to be different depending upon how far away you are from a mass, right? Those limits are going to change. And all the equations are there and you can look it up. We then applied those equations in 2006, 2007, something like this. We wrote a paper together where we derived precisely, and I mean precisely, experimentally verified sizes of the proton and neutron, and to astonishing precision. And we have exact solutions to both of those particles, their sizes, experimentally verified. Now, with respect to Lazar, the plug-in comes, I take those same equations, exact same equations, which have been experimentally verified for the proton and the neutron, right? This is all historical fact. You can look it up. I apply those to the Lazar story, right? Now, I had no intention when I started the analysis. I had no intention. Bob Lazar never came into it. at all. Wasn't even thinking about it, right? But when I ran the numbers, my jaw dropped. I could not believe what I was seeing when I plugged the values for the Earth into those same equations. What I ended up realizing and seeing and proving and deriving was Bob Lazar's 7.46 hertz frequency claim. Now, I derive a value of 7.43, but that's because I use the particle data group value of nominal equatorial radius of the Earth, right? If, however, I use the US geophysics, I can't remember what the acronym is, right? What they're called. But if I use official US geophysics data, I get exactly 7.46. Not 7.43, exactly 7.46. Because as you know, the Earth is not perfectly spherical. It does vary, right? So if you actually use US geophysical science data, and that's in the article that I wrote. It's a bullet point paragraph thing. You can find it. You get exactly 7.46. So how? So the question really is.
So one question is, so 7.46 for what? For the lower cutoff frequency, or?
Okay, so 7.46 for what Bob Lazar calls, right, his gravity B wave frequency claim, right?
In terms of what the Earth is doing, though, you're calculating something based on the Earth. What's
correct.
the calculation done there?
Okay, so assuming, that's a good question. So let's we have to make some assumptions here, right? So assuming that a space alien craft was hovering at the surface of the Earth, and let's just imagine Bob Lazar actually saw it with his own eyes. For that balancing of forces, for the lack of a better description, I'll use the word forces, right? So for that balancing act, okay. And Bob Lazar actually claims this, that there were 3 gravity amplifiers, and those gravity amplifiers pulsed with a rotational frequency of 7.46 hertz. So he said he witnessed the Martian spaceship floating, right? You know, like at eye level at the surface of the Earth. So let's assume, for example, that balancing act is a 7.46 hertz frequency rotation around those gravity amplifiers. That frequency rotation value in that balancing act must be equaling the so-called gravity B wave that Bob Lazar claims is being emanated from the Earth, right? Has to be equal, right? Okay. However, I questioned Bob's understanding of this gravity B wave. Bob claims that there are 2 forms of gravity A and gravity B. What I demonstrate in my YouTube channel and indeed in the article that I wrote, there is only one form of gravity. It's not 2, there's only one, right? So that's the first thing I've got to rule out. What Bob didn't seem to know was if you apply a Fourier analysis to the constant gravity that we experience at the surface of the Earth, and if you break it down into Fourier harmonics, if you add the first 415 harmonics together, you get greater than 99.9% the value of G at the surface of the Earth. Well, the resultant frequency from the addition of those first 415 frequency modes, is 7.46 hertz.
Sorry, the resulting what?
Frequency of adding those first 415 modes of gravitational acceleration.
So like a beat frequency? Or
sorry?
Is that the beat frequency of, because these are all sines and cosines being added, right?
Yeah, correct, but it's not a beat frequency.
Or
It's not a
cosine?
beat, right?
All
So
right.
right. So and I show this graphically, and you can see, like, if you watch my video, I think it's number 50. If you watch number 50, where I derive Bob's 7.46 frequency hertz value, you'll see how the Fourier system behaves when you add the first, third, fifth, seventh, etc. harmonic. You can see that you end up with a constant function, right? Now, when you add the first 415 modes in that gravitational acceleration spectrum together, the resultant frequency at the 415th mode is 7.46. So in a Fourier series, when you keep summing,
I'm not really sure. I'm not sure how that's. So is that do you by frequency? Do you mean the periodicity of, because when you sum all of these sines and cosines, you're going to get some waveform out of
correct?
that. It's not just a sine or a cosine. It's just going to be a messy waveform.
No.
So
No.
So you're saying when you add all of those terms, you're getting a clean sine wave
Well,
or cosine?
yes is the short answer, right? Yes is the short answer, but that's oversimplistic. I show it very well on my. I would really urge you to watch episode 50, where I derive that 7.4. I show viewers how it's actually derived, right?
Okay.
You take a square wave, right? You take a square wave, and as you would know, using Fourier harmonics, you can reproduce that square wave precisely, exactly square, by adding an infinite number of sine waves together in a certain way, in a Fourier way. Okay. Now, if you then fully rectify that square wave function, what do you end up with? A constant function.
Okay.
Right? So I show viewers that when you add the first 415 waves, Fourier waves together, and each one of those waves is a gravitational acceleration curve, it's a gravitational acceleration wave, I explain why we don't perceive gravity as being a periodic function, why we perceive it as being a constant function. Because in the case of the surface of the Earth, we are not just summing naturally the first 415 modes, we're summing 10 to the 28 modes, right? So you're summing so many modes, we experience it as being constant, right?
I mean, it's converging to, like, if you have if you have a Fourier series that converges to a square wave, then adding more modes is not going to change the fact that it converges to a square wave. I'm not really
Correct. So that's excellent point, right? And I speak about that in the video as well, in the sense that what I show is beyond 415 modes, right? So the question is, why stop at 415 modes? Because 415 modes yields 7.46. Why stop there when you can go up to 10 to the 28? Another great question. I'm glad you asked. And that's the kind of thing that you're asking. The reason why it stops, or I stop or the Martians stop at 415 modes is because of the principle of diminishing returns. I demonstrate that to go from 415 modes, so summing the first 415 to summing the first 1015, requires 36 times more power amplification for virtually a trivial amount of benefit. So that 415 mode limit, summing to the 415 modes, or summing to 7.46 hertz, is the most intelligent way and the most energetically efficient way of interacting or counteracting gravitational acceleration at the surface of the Earth.
Well, that doesn't answer my question about why it doesn't why the limit isn't a square wave for the full series.
So sorry, can you repeat that again, please?
Well, my original question was, okay, so if you're summing this thing and it's producing a square wave, then if you keep summing it, if you have a Fourier series for a square wave, even if it has 10 to the 28 terms or something, it's still going to converge to a square wave. It's not going to converge to a flat amount. So
no, but but if you take the magnitude of that function, right? If you take the magnitude of that function, engineers do it all the time, right? So if you fully rectify that square function, that square wave function, what do you end up with? A flat line, right?
Oh, okay.
Or alternatively, if you don't want to fully rectify it, right? So if you don't want to take the magnitude, what you can do is make the starting period of that wave function, make it 100 trillion years.
All right. So if I'm understanding correctly, the fundamental insight here may be that if you have a quantum vacuum and it has a non-zero energy density throughout space, then because that's equivalent to a function with a value of 1, you can decompose that into sines and cosines to get all of the individual wave modes.
Bang on.
Gotcha.
Bang
And then by restricting the wave modes, you get like the Casimir force and all these other effects.
Bang on. That's exactly correct. That's exactly correct. So when you say by restricting, I'll just add on top of that. I'll put a bit of special sauce on top of that. I'll say that the frequency limits of the quantum vacuum are impacted or restricted by the matter present. So if you take the Earth, for example, and
it adds boundary conditions like any Casimir force.
Yeah, correct. That's exactly right. Yeah.
So on the cosmological scale, why is the Casimir force repelling then?
Well, because virtual particles are popping in from what I've referred to as the dark reservoir of quantum potential energy. They're popping into existence momentarily. So that popping in, that creation annihilation process is forcing the expansion of space-time because it's happening everywhere.
But like most of the universe is mildly ionized plasma, so it's electrically conductive just ever so slightly. And if you have electrical conductors via the Casimir force, those should attract, right?
I think I understand what you're trying to get at. So, Howard, let me put it to you this way. Imagine you had a region of space a bazillion kilometers from anywhere, right? And you had no energy of any form propagating through that. There will be no charge, there'll be nothing. It'll have zero net charge, right? So let's just imagine that. The Casimir effect in that volume of space is still there. So virtual particles, that creation and annihilation process is still continuing. And every time particles pop into existence momentarily, that forces space to expand. New space has to be created at the periphery of the universe to accommodate the energy that's just popped in from the dark reservoir. Do you follow me?
Okay. I think maybe.
So it's that I've been trying to think of an example to help better understand it. Let me just take a sideline for a moment. I'll give you an example of something else that's not related to it, but maybe it's a bit of food for thought, and it might help you out a little bit.
Okay.
I've written a paper called CMBR Constrained Milky Way Mass, Resolving the Hubble Tension. Right, I've written an article. That's actually now with that's in the peer review process, and I'm hoping that it gets published. Right. Okay. Now, and I've also actually done a video on this. If you look at my last video, you'll see I can't remember, it was 73 or something, I think the number is. It's called Milky Way Mass Addendum. What I do in that is, in that article and in that video, I explain the Hubble tension. Okay, and I say the Hubble tension is in fact fictitious. It doesn't really exist. That's the one, right? Okay. Now, what do I mean by it doesn't really exist? Good question. Is there a difference between the power spectrum Hubble constant and the cosmic distance ladder Hubble constant? Yes, there is. So that difference does exist. When I say the Hubble tension doesn't exist, what I mean is it's unexpected. It's expected. It's not unexpected, right? So if you consider a galaxy as a point mass, and you think of it as being a space-time drain, whatever object that we look at through our telescopes, or whatever we observe to measure the distance ladder Hubble constant, the closer it is to the center of mass, the closer it is to the drain in that space-time drain in the galaxy, we will measure a higher value of cosmological expansion, because in the background you've got actual cosmological expansion occurring at I calculate like 61 kilometers per second per megaparsec, right? But in addition to that, you've got the object that we're observing using the distance ladder technique. You've got space-time not only expanding in all direction, but you've got space-time flowing into the center of mass of that galaxy. So you've got two things happening, and that's why the Hubble constant, when measured via distance ladder techniques, is higher than the Hubble constant measured by the power spectrum method, right? So
interesting. Except why would you see a redshift if something's lensing from just behind a galaxy instead, for example? So they still see redshifts in those cases instead of a blue shift.
Yeah, I don't yeah, but I don't
so
understand you.
If this galaxy is kind of like, anyway, never mind it for now. It's
yeah, all right. Well, look, I would urge you to watch that latest video plus number 50, right? Anyway.
Yes, and I'm sorry. Also, I watched a bunch of these videos long ago, and it's been a while. It's been a while, unfortunately, since I had all the pieces together on this. So,
50.
Just doing my best here. Sorry about that.
Rick,
no worries. So I'd recommend you watch 50, and the other one that you put on, I think it's 73 or something. Right. Anyway,
will do.
I have a couple questions, if you don't mind.
Yeah, sure.
It's going to get asked, because it was one of the things I had, other people had said and I had said, but that's the frequency it's very close to the Schumann resonance, 87.83 hertz. Is it? Do you think it's possible that Bob knew about that? And
no, not at all. And I'll tell you why.
Yeah.
Look, I actually list out the reasons why, and that's one of them in the article, right? And I've actually done a video of it, right? The Schumann effect. But I'm going to really dumb it down and make it the simplest thing. 7.83, the Schumann effect, 7.83 hertz, is known to two significant figures. End of story. Bob Lazar states his value to two significant figures. On that argument alone, the two are not connected. On just that argument.
Gotcha. Well, I mean, he might have switched the 6 for an 8 and just got it.
No. It's too much of a coincidence that 7.46 can be derived using Fourier mathematics. It's too much of a coincidence.
So did he also mention that there was a square wave pulse on these things? Is that why we're
No. He just said that He said that there were three gravity amplifiers configured circularly, right, equidistant, and that the pulse traveled around these three at 7.46 hertz.
Oh, so where does the square wave come from then?
Look, no, that's my idea. That's my solution to it.
Interesting.
Right.
So so in principle that could just be, again, curve fitting of the Fourier series to match up, though, right?
Yes is the short answer, but what you mean by me or by Bob?
by you here. It's like just a if you choose a square
No,
wave
no.
of 7.8.
No. I didn't. No. I didn't match it up. I didn't match it up. No. I looked. I actually just did. I did the calculation because the technique for my solution to the Bob Lazar story is the same technique that produces experimentally verified sizes for proton and neutron, right? That Todd and I published.
So you have some Fourier series, and it happens to converge to a square wave with this 7.864 hertz.
Correct. Well, look.
Okay.
Again, yes is the short answer. You need to watch the video because you can keep adding harmonics to get a better and better approximation to a perfect square wave if you want to.
I vaguely recall that part of it. Yeah.
Right. Okay. But, so the question becomes, why stop at 415?
Yeah.
And this is what. Correct. So there's no trickery here. I mean, it's straightforward mathematics. It's not even physics. It's mathematics.
So this is the work you did with Quinta Essentia with Jeff Deemer and Todd Desiato, right?
Yeah, that was part one.
So it's basically you take in this Buckingham pi theory and you fine tune all these constants in it until you get protons, electrons, neutrons. You get all the particles with their values and every. You get our universe. Yeah. It's kind of like. Is this like a Goldilocks kind of equation where you're just fitting the curve to with the Goldilocks just until right?
No. So your understanding is fundamentally correct. What I would dispute is your choice of words. There is no fine tuning that has ever occurred. No reverse engineering of any description. No working backwards from it.
So how do you choose the weights on your Fourier series though? Then for any of these?
What do you mean?
So I just have to look back at the model and see how it's done, perhaps.
Yeah. Look, if you start, okay, if you start from, look, you can either spend a lot of time reading the papers, and they've all been published. Right? It's all been there since 2005, right? Or a lot of it. That's when it started, right? Or you can watch the videos, and I would say the easiest. Look, there's about 3 hours of video that you can watch, or there's 3,000 hours of papers that you can read. Your choice, right? So
I'll take the papers.
Yeah, right. So look. So basically, the real stroke of, shall I say, just to use an expression, the stroke of genius here was actually relating the rest mass energy of an object, or equating the rest mass energy of an object to the spectral energy density of the field surrounding the object.
So you have some idea of the size of these.
Correct.
Atoms. Okay. Yes.
Correct. Gotcha. So once you know a particle's mass or an object's mass, everything drops out. Right. So your quantum vacuum limits drops out because you've got the mass, the rest mass. You see.
All right.
Otherwise.
Sorry.
So I was just going to say, otherwise the Fourier spectrum is always infinitely broad.
Got you. Yeah, because there's nothing to bound it otherwise.
Correct.
So you have some geometric, you have some boundary conditions effectively, and those boundary conditions say everything about the system.
Yeah, that's exactly right.
All right.
That's exactly right.
Got you.
So what we've been able to do, look, Todd left, like, I mean, Todd and I worked for decades together, right? We worked for a long time together. Now, Todd basically went in one direction and I went in another, because as you know, Todd's passion is warp drive, right? My passion is gravity, not warp drive. So from, and as you know, those two things, they really go hand in hand and they're very closely related, right? But there came a point where, we had to diverge, right? So look, fundamentally, Todd and I took on a very basic level, and I cover this in my videos as well. We took Hal Puthoff's polarizable vacuum model of gravity, and we advanced it decades. We advanced it to a point that Hal Puthoff has no way of understanding, and I know he doesn't understand what its full potential, because he hasn't invested the time in it.
Yeah, I hope he does take a look at it after this, though.
Oh, look, interestingly enough, on that Lazar article, Hal contacted me, and he said, "I've had a look at your. I'm reading your Lazar article with interest," and I'm quoting him directly. And then he attached a table of refractive index equations in various situations. I suppose he wanted to send me the message that he came up with an original table, and he did, right? But the table that Todd and I have come up with just exceeds his by decades, right? And in fact, Quinta Essentia Part 1.
Where is that published? Where's the table with your and Todd's table published?
Oh, look, it's in multiple places, but it's in the Lazar paper as well. It's there, right? And Todd actually was very largely responsible for the contents of that table, but it's been published many times now. And that method that I've published in the Lazar article, that method has been published multiple times as well in EGM Part 4 in EGM, a practical guide to space-time engineering, was published in Physics Essays number 4 in like 2009 or something, or 7 or something like this, and then it was published again in 2011 at a conference that I delivered in the US. So that same technique has been republished a number of times, and the Lazar article, yeah, that's it. It's in there as well, and it's also in the Lazar article. And in that Lazar article, I just want to highlight that I've created 3 versions of that article, right? So the complete version, which is the one that most people will see, that's really geared towards people like Michael, right? That has a scientific background, and people, someone like Michael can read that. If you've got the interest and the motivation, you can go through that and you'll get your head around it, right? Then I did another version, which is on the linked data tab of that ResearchGate page, which has what's called a succinct version. So that has all of the I suppose the waffle and the wow factor extracted out of it, but still contains the mathematics, right? So you, Michael, might be interested in that one as well, right? It's a shorter version. It saves, I don't know. So
this refractive index table, is this refractive indices of the near fields of the particles, or of different?
Well, it's a generalized description of how you calculate the refractive index for anything, and if you scroll down, if you keep scrolling down,
in a polarizable vacuum model. So this is it maps 1-to-1 to curvature.
Yeah, correct. Yeah, correct. And then there's back to what I was talking about, the linked data tab. There's what I call the core version, and the core version is for the average guy on the street that has very limited to no mathematical understanding. I hope they can read a basic equation, and it's more or less just the words, right? With a couple of key equations there. But for someone like you, Michael, I would suggest either the complete version, or if you can't be bothered printing that many pages out, go for the succinct version.
Gotcha.
Right? Because I know you will be able to get your head around it.
Appreciate it.
Yeah.
Yeah, I'll take a look.
Yeah. So Jeremy, what other questions might you have in the Lazar space? Look, can I just reiterate something that I talked about before? I just want to keep reiterating this because I believe it's really critically essential. Look, Michael, and I'm speaking, passionately to you about this in particular. As a scientist, Michael, you know that credibility, human credibility and testimony is worthless, right? It's all about the testable science. What the media needs to do, people like Jeremy Corbell, George Knapp, Richard Coulthard, who is Australian, I'm very ashamed to confess to, right? What these guys need to do is move away from the wow factor, because that's all they do. They focus on the wow factor. And we need to move as a community of interested parties to the testable science behind Lazar's claims, right?
I agree.
And
I agree. Yeah, because so far it's been focusing on the personal and the ad hominem to attacks and stuff.
Yeah,
there's good reason, because it makes good television, and they're making money off of television, more or less. And I mean, that's the goal, is to keep people to get a source of income, and also to keep people distracted and unable to make real contributions, in a sense. Although,
Michael, I agree with you 1,000,000%, infinity percent.
It's divide and conquer. It's as old as time.
Absolutely. So what I've really tried desperately and very, very concertedly I've tried to do in that Lazar paper is to strip all of that rubbish away. And that Lazar article, it really is written for an audience like you, Michael. It's not really written for your Coulthards, your Corbells, or your Naps. Right? It's written for people like you. And there really is science to at least one, I will say not all of Lazar's claims, but at least one. There is testable science to his claim. And look, I've constructed it in such a way that I believe it is basically irrefutable, because it's more mathematics than it is physics. Right?
Well, all right. I mean, the assumptions are where the physics lies, and the interpretation.
Yeah, correct. So now, with respect to one thing, I should add, right, and this relates to quantum mechanics, and you will appreciate it. I interpret, and in fact, we all should interpret, like when you have a wave function, okay, the amplitude of that wave function is actually a probability amplitude, and that is how we need to interpret when we decompose gravitational acceleration at the surface of the Earth or around any object. The way I've done it, viewers need to interpret the amplitude spectrum, because there are in fact two spectrums occurring here. There's an amplitude spectrum and there's a frequency spectrum, right? The amplitude spectrum needs to be interpreted as the probability amplitude. So the probability of gravitons being absorbed by the 0-point field, or of the 0-point field returning virtual particles in response to that absorption process. So what I claim is happening is this, that matter radiates gravitons. Those gravitons are conjugate photon pairs which are entangled, right? So you've got a positive and a negative, right?
Gotcha. We interpret that. It's vacuum states, effectively.
Correct, right? So, correct. That's right. Correct, and that's very important, right? That's very important, because that shows you that doesn't break GR or anything.
Well, in fact, squeezed vacuum states have been known about for decades, and people just refuse to call them gravitons because they're a composite particle, and people think in the standard model that the graviton is supposed to be a fundamental particle, not a composite particle.
I agree with you totally, 1,000,000%, right? So what I claim is happening, and I've shown this mathematically, and I'm talking about cosmological time now. So over cosmological time, for every two, so one graviton, right, which has I'm saying it's two photons entangled, right? So for every two photons that enters the 0-point field, or rather specifically enters the quantum vacuum, the dark reservoir of quantum potential energy, which sits underneath the the 0-point field. For every 2 photons that enters that space, that location, 1 photon is returned. On average, I'm using averages now, right? 1 photon is returned from the dark reservoir of quantum potential energy to the real.
How is that possible? Because in every particle collision in physics, you have 3 objects. You have one going in, or you have 2 going in, and you have 1 thing coming in. So like every vertex in particle physics is always with 3 objects. So if you just have 2 photons going in and becoming a graviton, that's all well and good. But then how does that graviton just release 1 photon?
Okay, so look, that's a good question. Okay, so when that graviton, that entangled pair of photons, enters the dark reservoir of, and I've got to emphasize this, quantum potential energy. It's potential energy. It's not in motion, it's potential energy. The universe releases that potential energy in the form of the Casimir effect, which I claim is the driving, so that creation annihilation process of particle pairs, virtual particle pairs, right? That happens, right? So what I'm saying is, on average, across the board, across cosmological time, on average, you've got 2 going in, 1 coming out. What that means then is that over cosmological time, and I'm not talking about 15 billion years, 14 or 15 billion years, I'm not talking about that cosmological time. I'm talking about a minimum of 10 to the 13 gigayears. The universe becomes so large, effectively, we enter a cyclic cosmology model. So if you're familiar with Sir Roger Penrose's work, you'll know he's developed the conformal cyclic cosmology model, right? However, the missing ingredient in his model, and I've heard him confess to this, is that for his conformal cyclic cosmology model to work, matter is required to lose mass. And this is what I'm claiming. And this is the mechanism. So eventually, over 10 to the 13 gigayears as a minimum, right? Eventually, the universe expands so large, we effectively get a reset. It's like turning an hourglass upside down. So all the physical energy in the universe has then been stored into the dark reservoir of quantum potential energy. Potential, right? That's the really key word. Then when the last photon in the universe enters that quantum potential energy well, the hourglass flips and we get a new Big Bang. We get the next cyclic iteration. That's what I claim.
All right. And I guess to point out for our viewers, one of the important things about models like this is that potential is always measured relative to other stuff. But in a model like this, and in most polarizable vacuum models, you have a concept of actual zero versus
Correct.
potential that's everywhere. So
Correct.
mathematically, you can talk about that sort of thing. And so in that sense, it's an extension of standard physics models too.
Correct.
So but this is somewhat unrelated to this other point.
Yeah.
I don't know. So what would be the mechanism for that reset for this?
Look, I can't speak to that. Look, the only way I can answer that, the only way I can describe that would be like an egg timer or an hourglass. All I say is it happens. So the dark reservoir of quantum potential energy becomes 100% saturated. And I've done PowerPoint presentations of this and videos of this, and right. And in fact, it's in a published paper. A paper of mine was published. It's called "The History of the Cosmos: Implications for the Hubble Tension." It's open access, and it was published by oh God, I can't even pronounce it. They're called de Gruyter. Anyway, I presented that same paper at a conference in CERN. Sorry, at a virtual conference for CERN last year in December 2022. So anyway, that's the paper that's come out of it. It's been published. There's also a copy of it on the CERN server as well, and I actually include diagrams of a cyclic model of cosmology in there. I show how the cosmological constant actually varies with time. That's not truly a constant. It's actually varied, and I show all of this, and it all lines up. Everything lines up. 110% lines up with the standard model of cosmology. The standard model of cosmology is not broken at all in any way, shape, or form. Right? So the Hubble tension has not broken it. Anyway, sorry. All of this gets back to, with respect to Lazar, the same equations that we use to describe experimentally verified proton and neutron particle sizes, and also experimentally verified cosmology stuff. Those same equations, that same principle, is applied to the Lazar problem of 7.46 hertz. And I would also like to point out, and this I think is important for my own credibility and for American viewers there. We talked about this earlier, about credibility. In 2008, I published with the Australian Institute of Physics, once again, this is historical fact and fully verifiable, a power spectrum Hubble constant, because that's how I calculate it I derived it from the cosmic microwave background radiation. So it's true power spectrum Hubble constant of 67.1. I'm just rounding off, 67.1 kilometers per second per megaparsec. In 2008, the official PDG value for the Hubble constant, it wasn't even differentiated between power spectrum or distance ladder at that time. The official particle data group value for Hubble constant was 73 kilometers per second per megaparsec. In 2013, the Planck satellite confirmed or measured the power spectrum Hubble constant, and the PDG value in 2013 was 67.3, so virtually matching precisely my prediction of 67.1. Okay, now that value of 67.3 then became, with respect to the particle data group, 67.4, I think, in 2019. Anyway, now in 2000 and that continued right up until 2022. Then in 2023, the particle data group has now differentiated between the power spectrum Hubble constant and the distance ladder Hubble constant. So now in the PDG astrostatistical table that they produce every couple of years, you'll actually see that they've actually considered the difference because of the so-called Hubble tension, and they've actually published two values now. Okay, so the point that I'm getting to is that I accurately predicted 5 years in advance of experimental observation the power spectrum Hubble constant. Now, prediction is at the core of science. That's what all science is about. It's not about understanding anything. It's about predicting the future. That's what all science is about. What will happen if I do this?
Well, I mean, it's the saying is a broken clock may be right once a day or whatever, or
twice a day,
depending on where you are, if you have military time versus.
Yeah.
But in any case,
and a broken clock, a stopped clock's right more times a day than a slow.
But yeah, I mean, so I mean, it seems what you've got there is more than luck, though. So
yeah, correct.
So
that is precisely the point that I was getting to. Right? It's not just luck. Right? You don't get that lucky. Right? Look, in the case of the proton, right? I think I derived that Todd and I wrote that paper, I think, in 2006. At the time, the most accurate data for the proton was the measurement by the Selleck's collaboration. And the value that we came up with, like the exact, so Todd and I came up with exact analytical solutions for the proton and the neutron, right? Now, the exact proton analytical solution is so accurate that the Selleck's collaboration, who actually did the measurement of the size of the proton, they did not understand how accurate their measurement actually was. So when you combine a material like this with the 2008 prediction that I made, which has been published 5 years in advance of experimental observation, this is too powerful to dismiss as blind luck. And these are the same equations and principles that I apply to the Lazar story. And this is what convinces me that there is truth, at least to some level, about what Bob Lazar was saying. I don't care about the man. I don't care about his personal story. I don't care if he's lied. Let's imagine.
He predicted in 1989 that we would discover a stable form of moscovium, or element 115.
Yeah.
No, he didn't say we would discover it. He said that it was impossible to make on Earth, probably, which is very near impossible. I mean, you have if there are any stable nuclear isomers, not nuclear isotopes of moscovium, then you would need to redo the experiment that made moscovium, and you'd have to do it in a dense stream of gamma rays that are of the appropriate frequency to merge with the unstable element 115 and stabilize it into a nuclear isomer, potentially.
So
anyway,
I know, Michael, you and I have talked about isomers in the past, and you're absolutely correct in that there's not just isotopes that the world should be speaking about. There's also isomers, and we've had that conversation in the past. I would urge you to review my Bob Lazar playlist, because in there I actually, and again I asked you to do it in sequence, right, in numerical sequence that appears in the playlist, right, and it needs to be like that because I keep building on each one. What I do is I actually derive, my prediction is the stable form of moscovium is isotope 296. That's my prediction, 296. And I show...
And that's not an isomer, it's an isotope?
Correct, an isotope, correct. Right?
Interesting.
So that's my personal prediction. And it's not too far off the theoretical prediction of a stable isotope. So I would urge you to have a look at that. I walk through I walk through all the logic for it, etc. So look, I had hoped not to talk about element 115 or moscovium here, because look, there is a big question mark about this, and I don't want to give viewers the excuse to poo-poo the real meat and potatoes in the Lazar story, which is 7.46.
Yeah, if you've got an equation and it makes good predictions, and then it does this too, maybe there's something there. It's just, I guess the other question then is, where would we take it from here? How does this measurement based on Lazar's work and your equations, what does this tell us for experiments? What might we predict next?
Look, that's a really good question. Okay, so look, my answer to that question. Look, I haven't rehearsed this, so this is all ad hoc. So the way I would answer that question is this. Okay, in one of my videos, I actually and indeed you may have seen, like, I've produced MathCAD files, PDF files that are huge, right? So I actually derive a solution to the many order, what's called the many orders of magnitude problem. So the problem is this: why are there 10 to the 42 orders of magnitude difference between the electrical force and the gravitational force? It's a fundamental question in physics, right? Why is there so much of a difference between two forces that look basically the same? They behave basically the same. Okay, so I actually derive a potential reason for that. So what I show is that, according to me, again, this is according to me, that the reason why this 10 to the 42 orders of magnitude exists is because the electrical force occurs at 90 degrees out of phase with gravitational force, right? However, in the case of element 115 or moscovium, if what Bob Lazar says is true, and if it does in fact have anti-gravitational properties, right, then that phase shift is no longer 90 degrees. It's either 0 or 180. That is the difference that I'm claiming. If it exists at all, that's what I believe the difference is. And I've done videos all about this as well. And I would encourage you
more than just an element that we might not otherwise have. So what experiments does this lead to, though, that we can actually do?
So that was going to be the next part of my answer, right? So the next part of my answer is, I would then take, in terms of experimentation, I would then take a closer look at what Todd's doing, right? I would use Todd's work as a guide to further experimentation. So I would plug in my idea of a phase difference between the electrical force and the gravitational force, that 90-degree phase difference, and I would look at ways that we could potentially reduce that difference to 0 or increase it to 180, whichever, right? But Todd's work may be, and I can't say for certain, I'm guessing here, Todd's work may be a good place to start, right? Because I know he's done, look, Todd's worked, side by side next to me for decades, right? Todd has an interest in warp drive more so than gravity. So what I'm suggesting is these two concepts can be now perhaps recombined in the manner that I've just described. So I'm guessing Todd might actually have some good experimental ideas to work from in that space.
For some additional context on that, what exactly do you mean by this 90 degrees out of phase, or 0 or 180 degrees out of phase between electromagnetism and gravity?
Okay, so I actually, again, I will say that I would encourage you to have a look at the videos that I've produced and the very mathematical MathCAD PDFs that I've produced, where I've laid everything out step by step. Look, it's difficult. It's not easy for people to go through. You could do it. I know you could do it if you can find the time to do it, right, and the motivation to do it. But you'll see how I explain why there's that difference. And in summary, it goes like this. We've already talked about decomposing a constant function, right? So we've already talked about that. So I've done that for gravity. If you do that for charge as well, right, what you end up with is an equation that, when you include a pi on 2 factor, that equation equals 1. You've discovered it. That's it. The difference is a phase shift of pi on 2.
Interesting.
Right? So that's what I show in my videos, and in that all that mathematical work that I've done. Now, the reason I don't sort of go further into the experimental side of things, which I talked about getting more involved with Todd and you guys. I know you guys do a lot, and you do a lot of great stuff. look, I mean, Jeremy knows my story. Todd knows my story. Perhaps you know my story as well. I'm not particularly well at the moment, so my emphasis is on my medical treatment, and in fact, I'll be starting a new line of treatment on the 12th of February. So I've had already. 2021 for me was a year from hell. I had 2 bone marrow transplants. I spent the entire year in hospital. Damn near killed me. I'm not going to do that in 2024, but I've got other treatment, a new line of treatment. I've had some of these chemicals before, and they are just, they really fuck you up, to be honest.
That's the chemo, right?
Yeah, the chemo. So,
yeah, and we're wishing you the best of luck with it too.
Yeah, thanks, Marty. I appreciate that. And look, just for any viewers that might be interested, a word to the wise. I mean, look, I know steroids are out there in abundance because of bodybuilders and et cetera, et cetera. Let me tell you this, viewers, just as a side note, and I really want to emphasize this because it's all based upon personal experience. Steroids, there are a reason why steroids are available only by prescription, okay? Because it's powerful stuff. And steroids is a standard treatment for, I think, for at least all forms of blood cancer, maybe other cancers as well. I don't know. I've got blood cancer, right? And when you're on steroids, oh my God, you become emotionally incontinent. So you have no control over your emotions. You literally, after about 5 weeks, lose complete control. Someone can do the nicest, most trivial thing for you. They can hold open a door, and you'll burst into tears, or you can fly into rage over nothing. So a word to the wise people, people out there that are thinking about steroids, don't do it, right? Because it's very powerful stuff. Anyway, that's just one of the chemicals, but I just wanted to mention.
Throw off your hormonal balances, it's not good. Yeah.
Yeah, that's right.
You gotta, if you do steroids, you have to and you want to switch off of something, you gotta taper it down over weeks or months, typically.
Yeah, well, that's right. So that's why in cancer treatment, what they do is you take steroids for a period, then you take a break, then steroids for a period, and then you take a break. And that's how it works with blood cancer treatment. But anyway, I just wanted to mention that because stuff that I've learned, I just want to pass on that.
No, I learned. I worked for an old boss of mine that did a lot of steroids for weightlifting back in the years ago, and now his body can't produce his own testosterone, and he has to take testosterone treatment just to.
Yeah. Oh, and by the way, and here's something else, right? Here's something, and this is, look, we're all men here, and for the male viewers watching, pay attention. Steroids reduces your libido to zero. Okay? So keep that in mind, right? If you want to be completely sexually dysfunctional, take steroids. Right? Who wants that? What man wants that? Right? So kids, if you're watching,
you'll be able to get the girls with the big muscles, but you won't be able to do anything with them.
That's right. That's right. So anyway, look, enough of that. Back to Lazar. So what I really wanted to an example of the way I perceive Bob Lazar that I want to spread and hopefully the message gets out there. Look, let's just imagine for the sake of argument that Bob Lazar was a janitor working at S4, okay? And his job was to clean up and clean toilets. And let's just imagine he found a document that had this space alien information in it. So what? I mean, what's important here is the content of the document that he found as a janitor, for example. The fact that he's a janitor is irrelevant. Who cares? Right? And anyway, that's the point that I wanted to make.
I've been investigating
these things are orthogonal to the science. Like you can do whatever social posturing, but at the end of the day, sociology is not a hard science, and math and physics are.
Correct. And look, I mentioned to Jeremy before, Look, the only reason I agreed to come and talk to you guys, I mean, to be honest, Michael, I didn't know you were going to be here, but I'm glad you are, right? Was because, look, Jeremy, I've got a great deal of respect for Jeremy Rees, so I just wanted to mention that because we've had a bit of a past anyway. That's all good. I was contacted by Jeremy Corbell, and I had actually reached out to Jeremy Corbell previously, and he had ignored my correspondence. And to me, that is just really severely rude, right? Anyway, the reason I'm happy to be involved with this is because we're talking about the science. I'm not interested in the sensationalism, the wow factor about the Lazar story. Couldn't care less. I've got enough issues in my own life to worry about. We all do. We all do. I know, Jeremy, you've got kids, and I don't know what your situation is, Michael, but I'm sure you've got lots of problems of your own, right? So I just wanted to focus on the science, and that's what I wish everybody would do.
It's also important that in order to be real scientists, we always have to be able to change our position based upon new evidence, regardless of how much we buckle down, how much I've become the #1 Lazar debunker on the internet. I'm always willing to change my opinion based on new evidence. And we should always be willing to say, hey, listen, I might have been wrong. And let me check myself.
Look, you're absolutely correct. And as I said to you before, look, it takes a big man to do that. It takes a big man to do that. I mean, Stanton Friedman, for example, who has now since left us, he's passed away. I had a bit of contact with Stanton Friedman. So before I wrote the Lazar paper, I had all the mathematical evidence, and I reached out to him and I said, listen, there's some good science here, right? Would you be interested? He wasn't interested at all. He was all he wanted from me was, what do you have element 115? Do you have a sample of it? I said, well, of course I don't. Right? Stanton Friedman was not interested in the science behind Bob Lazar at all. Right? Stanton Friedman was a character assassin, and it shocked me, coming from a nuclear physicist. It shocked me that a man who should have been playing the ball and not the man was playing the man and not the ball. Right? He put his reputation on the line based upon documents that did or didn't exist. Well, all these documents can be faked, all of them. So let me just hang up on this because a phone call's just come in, and I know exactly who it is. It's an Indian scammer group, right? So I just hung up.
I thought you were going to say it was Corbell calling you.
No. It's an Indian scammer group. So I know exactly who it is. I've seen their style 1,000 times, and that's why I hung up with them. So I just wanted to mention that. Anyway, back to Stanton Friedman. It actually shocked me no end that Stanton Friedman, a supposed trained scientist, so he claims to have worked for this and that and the rest of it. I mean, I don't know. Maybe he did, maybe he didn't. But he certainly didn't behave like one, because a scientist does not say, in my position, take the view that, well, look, there's no evidence of Bob Lazar's this, there's no evidence of that, or there's evidence that he's lied. That is not evidence. If it's untestable and non-reproducible,
it's still
it's not evidence
it's just
at all.
Circumstantial. It's not actionable.
Right. So one thing that I want to point about, that I really want to emphasize about my article with regards to Lazar, is that everybody that has the mathematical skills, and this is exactly you, Michael, everybody that has the mathematical skills can validate the claims that I make in that article, right? There can be no better proof than this. You're not required to rely on a government document or something someone said, like from David Grush or the rest of it. You can check it for yourself.
Yeah, we can go see that you published a paper. I'm going to go try to go through this at some point too, so I can make a short video going over all this. But we can go
Sure.
show the date on your paper, say that you published this and made such and such a prediction of this cosmological constant, and then afterwards it was confirmed to that degree of certainty that you made
correct.
it.
Yeah.
And that's all verifiable.
Yeah, that's all verifiable, correct. And it was published by the Australian Institute of Physics. I've got the link on my ResearchGate page. I've since tried to. The only way that you can officially access it now is through the Australian National University Library Archive. But I've actually got the CD as well, so I'm happy to upload the contents of the whole CD, because it wasn't just me; it was me and a whole lot of papers published, right? So I'm happy to give you access to that. I can zip it up and I'll put it on Dropbox. You can download it for yourself and you can see. But it's all there. It's got an ISBN number and all this kind of business. But the actual PDF, which is, all officially labelled, etc., with the Australian Institute of Physics, it's all there. It's all there. So it's absolutely verifiable. But as I say, Jeremy, I'm happy to zip up the CD and make it available for you to download. I have no idea whether I'm breaking any Australian copyright laws or what. I don't care. I'll do it. So I don't think
I won't tell on you.
Yeah, look, I don't think they'd really care, because you can get it through their library anyway. These days now, I think since last time I checked, shortly after, so this was in 2008, right? Shortly after that, I think Australian National University has now made it all available, I think, from like 2009, 2010 or something onwards. All of this stuff available online, and you can download it. But I think I sort of just missed out on that window. But you can check it out. And ANU is, as the name would imply, it's a very prestigious institution here, Australian National University. So, it's connected to defence. It's because it's in Canberra. It's in our national capital, right? So, it's into everything, right? It's into everything. So, yeah, you can get all that.
Yeah. Sounds good. We'll take a look, and
no worries.
I mean, we'll wish you the best of luck.
Yeah, thanks, mate. I appreciate that.
Hopefully, get you back in touch with Todd so you can, just chat in case anything happens. You never know.
Yeah, well, look, I plan on taking some. I'm taking some time off. Before, look, I was actually supposed to start my treatment on the 8th of January, but I wasn't mentally prepared, because I know what's going to come, right? Because I've been through some of this stuff before, and it just destroys you. So I said to my hematologist, look, I'm just mentally not prepared now, and I've pushed it back a month.
Well, I guess that was a good thing, because I'm glad we could sit down and do this today, Rick. And
look, see, because I just want to point out. So for example, it is a good thing, because when I did that, when I participated in APEC with Jim Ventura, I mean, at the time, I was heavily medicated. I mean, you would not believe some of the medication that I had to take at the time, because I've got a secondary condition called peripheral neuropathy. So my feet are like 2.5 years ago, my feet were on fire literally 24/7. So imagine this. I mean, you guys can do it because you're in the snow where you are, Jeremy, at least, right? Take your socks and shoes off, go outside, walk around in the snow for 2 minutes, come inside and put your feet into a bucket of hot water. And that is what I was experiencing 24/7, 2.5 years ago, right? That has now, and I took so much medication to try and deal with that. It's actually a common problem for cancer patients, right? But however, I'm in the small minority that really got hit by a piano with it, right? Most people don't get it as severe as I do, as I got it. Anyway, that has now diminished to the sensation of walking on golf balls. So imagine you've got golf balls strapped to your feet, right? 24/7, and you've got to walk around with golf ball shoes. That's what it feels like, right? It drives you mad. So I've been, at the time of that Jim Ventura APEC video thing,
Right.
I was heavily medicated. I mean, endone,
Quite frankly,
Target,
I could tell.
tramadol. Yeah, right. And I'm not surprised. I mean, I was very heavily medicated. I mean, I was like, but because I'd made the
Like
commitment,
Meet the Osbournes, right? Like,
yeah, right. But because I'd made the commitment to Jim to do this, and how much medication I take depends. It goes on a day by day basis. You know, some days I have good days and I have bad days. You know, so it's good that it's happened now because, you know, after the 12th of February, I'm going to go down a well of misery. So, yeah, I just want to.
So you're not going for like a gene therapy approach where they modify your white blood cells or anything?
Good question. The short answer to that is no. And you know why? Right. Here's the kicker. I had 2 bone marrow transplants in 2021. So a bone marrow transplant is also known as a stem cell transplant. So what happens is you go into hospital, and they put one needle into one arm or hand and another one into another, and they collect your stem cells, right? Okay, so your stem cells are produced by your bone marrow, and those stem cells can become red blood cells, white blood cells, and platelets, right? It's like magical properties, seriously. Anyway, so they collected all those, and I had to go through that process 3 times, and it's a real shit because you're stuck in a chair all day, you can't move. Going to the toilet becomes an issue. I mean, I don't want to talk about it, right? So anyway, I had to go through that collection process 3 times. Then what happens, right? Then what happens, and I want to tell this story because I've learned so much in my cancer journey that I want other people to know about it because it could involve you, right? Okay, then what happens is you're injected with what's called a cytotoxin, and its name is melphalan. And what melphalan does is chemically delete your immune system to zero. So you have no immune system. And believe you me, you cannot feel any sicker than not having an immune system, right? And you become so vulnerable that the hospital locks you up in a room, right? Even the air is filtered, right? So even the air is purified so that nothing gets in, right? You're then re-injected. So, I mean, I'm compressing the whole timeline here, right? So then you're re-injected with your own stem cells, right? And then what happens is a measurement of your bacteria-fighting white cells, they're called neutrophils. So they get reduced to 0. You get re-injected with your own stem cells, and then that comes back up to what's hopefully a normal level, right? So I went through that whole process twice. The first time I sailed through it, right? The hospital was they were shocked and stunned. I just sailed through it. It was a miracle. That's the miracle, not space sail. It's not element 115. The miracle was traveling through this thing as easy as I did the first time. The second time nearly killed me. It nearly killed me because my own body, because I had no immune system, my own body attacked me and attacked me viciously. So much to the point I was shaking so violently I felt like my bones were going to break, right? At midnight, I was almost going to call my mother and say, listen, Ma, that's it. I'm done. I'm finished. Get in here. I want to give you a kiss goodbye, and that's it. This is all in the middle of a pandemic, by the way. So I didn't have any visitors or anything. No one could come and visit me because it's in the middle of a pandemic. Anyway, so the doctor comes in and says, oh, my God, all right. So they shot me full of pethidine, which is a wonderful drug. I highly recommend it. Right? Shot me full of pethidine. And that knocked me out and got rid of my shakes, etc. Anyway, I recovered out of it. It was real touch and go there for a while. So I had a hell of a 2021. So that's why. And then and 2022 was good. And then halfway through 2023, my cancer rebounded, and the cancer's just now been, the cancer cells been growing. and now I'm re-experiencing all the fatigue and stuff because I don't have enough red blood cells. Anyway, so it's good that we've had this chat now. I've got to go back into treatment on the 12th of February, so it's good timing. Look, I realise I sound like I can talk like I'm, I sound like I'm talking under wet cement, and I apologise for this. And for God's sake, Jeremy, I want you to edit out all of this rambling. Okay,
Well, it's been nice talking to you, Rick.
Yeah. All right, guys. Thanks for everything, and have a great day. And I know it's late there. Michael, I'm curious. Where are you, and what time is it for you?
Oh, me? Oh, I'm in the same building Jeremy's in, actually.
Ah, okay. So it's like so what time is it there for you guys?
Oh, right now it's oh wow, is it that late? It's
8 p.m. Yeah, I got to get going.
8
Oh,
p.m.
okay.
But
All right.
thank you for taking the time to do this with us, and I'm glad.
Yeah, look, no worries. And look, please be kind with the editing, okay? Because I know I come across as a rambling lunatic, so you can probably
Don't worry about it.
Don't worry about it. We'll figure
All right,
it out.
fellas. So look, Jeremy, I'm going to zip up that CD I was telling you about. I'm going to zip it up into one file. I'm going to put it on my Dropbox. I'll send you the link, but you can access that verified 2008 thing. You can access on ResearchGate anyway. The CD is just going to be a bundle of other stuff plus that one. That's all.
Sounds good.
All right. Thanks, guys. I'll talk to you at some other point.
There's an Australian YouTube channel, Explosions and Fire, very entertaining. Extractions and
really?
Fire as well.
Okay.
Good Australian comedy.
If you want another funny one, right? There's a I don't know what the channel name is, but if you type in Superwog, right, all one word, Superwog, W-O-G, Superwog, all one word, W-O-G, some of the content on that is fucking hilarious.
Nice.
Right?
I'll do
So,
it. And yeah,
I
you check
reckon-
out that other one. It's a chemistry YouTube channel, and the chemistry YouTubers are very funny, generally speaking, strangely.
I like all the Australian YouTubers, man. Robot Head. Oh, he's great.
Something to get you through the hard times, maybe. Just watch some funny
That's
YouTube videos. Yeah.
I'll keep it in mind. All right, guys. Thanks a lot.
Anytime, man. Give me a call.
Have fun.
We'll do. Cheers.
Or
Bye.
try to.
Cheers.
luck.
Bye.